All right. Good to have you here. Christophe Mouël, PhD, was trained as a quantum physicist and did theoretical research in high-energy physics for several years in France and Greece. He also worked as a project manager at the National Center for Nuclear Energy in Paris, France, before moving to Los Angeles in 2007. Fascinated by the connection of physics and psychology, he lectured internationally on this topic, and he is currently the executive director of the C.G. Jung Institute of Los Angeles and the science editor of the Jungian journal Psychological Perspectives. He's also adjunct faculty at the Studio School, where he teaches physics. That's where I came across him, where I teach philosophy. Please welcome Dr. Christophe Mouël.
Yeah, we have a lot of connections between the University of Philosophical Research and the C.G. Jung Institute. One of them is David Orr, who is going to be featured as one of the artists in the journal Psychological Perspectives, probably in September. So probably we're going to see his art in the journal, either on the cover or on the back cover. So I'm very, very honored to be here. It's such a beautiful place. Greg showed me the library, and I've never been here, so it was really a treat to see this place, and well, this big lecture hall as well. It's really nice. I envy you. What we have at the Jung Institute is much smaller. So today I want to talk about imagination. And I want to connect this topic to physics, which seems like a very strange combo. So I would like to address an important question concerning physical exploration. And this question is there a place for imagination in the universe? In other words, is imagination a spurious addition to the universe? Some kind of dazzling makeup which, when removed, would leave the universe fundamentally unchanged? Or is imagination integral to the cosmos? So I think that it's pretty interesting question. So the word cosmos and cosmetic share the same etymological root in the Greek word cosmos with a K, which essentially means order. Cosmos means order. And the verb kosmein, the Greek word kosmein, means to prepare, but also to adorn, to dress. And when using the word cosmos, we suggest that like an attractive woman, the word is carefully ordered, prepared, adorned, dressed, and we might wonder how this sophisticated order we discover around us came about, and delight in the description of its magnificent forms. Physical science is about this, the consideration of the lawful, orderly structure of the material things. But as we will see, modern quantum mechanics increasingly reveals that cosmos is in the making. We cannot reduce a future to a recurrence of the past, and we are bound to imagine what might be observed in the present. This does not mean that reason fails entirely at this point of scientific exploration, only that reason needs to be supplemented by a coherent form of imagination. In an essay written in 1784, philosopher Immanuel Kant described the Enlightenment as an age of reason where man threw off the yoke of knowledge, especially in religious matters. And he wrote, "Enlightenment is man's emergence from his self-imposed knowledge. Knowledge is an inability to use one's own understanding without another's guidance. People have reason, but they had to be helped to do that. And so suddenly they realized that they could do that by themselves. This knowledge is self-imposed if its cause lies not in lack of understanding, but in indecision and lack of courage to use one's own mind without another's guidance. Dare to know, sapere aude. This is something which is very important in philosophy. Have the courage to use your own understanding is therefore the motto of the Enlightenment. Kant borrowed his sapere aude from Roman moral poet Horace, who wrote in his epistles to Lodius that one should not postpone living well like the foolish deer who waited for the river to run off to cross it. Dare to know, that is, jump in the ever-flowing water of life. It might be that we should also throw off the spiritual idea that God created the universe at the beginnings of times, then left it run its perpetual course that we now contemplate from the dry bank of divine consciousness, as detached observers. Dare to imagine. Dare to imagine might become the motto of a new phase of enlightenment, where man consciously realizes its intimate participation to the creative flow of the cosmos. So I would like now to see how this development occurred over time. And so I'm going to talk quite a bit about classical physics, then a little bit about chaos. There's more to say about chaos, of course, but I'm going to be very brief. Then I'm going to talk about special relativity and general relativity. It's going to be also a little bit brief, so maybe a little bit hard. But I think that I just want to give you a few ideas about what it is. And then I will go to quantum mechanics. And in the end, I would like to give you a dream showing, it's a big dream that I had many years ago, around 2000, that really shows for me what the universe is about and how creation happens. And I believe that it really happens all the time. And this is what quantum mechanics is saying. And I wanted also to talk about new interpretations of quantum mechanics, in particular cubism, and show how it's connected to Jung's ideas. But it might be a little bit, I may not get there, so we may want to keep that for the questions. So the age of reason loosely, so I'm going to talk first about classical physics. The age of reason loosely started around the 17th century with the discovery that the universe in its entirety is orderly, and that this order is expressed in the language of mathematics. As Galileo famously wrote in 1623, philosophy is written in that great book, which ever lies before our eyes, I mean the universe, that we cannot understand it if we do not first learn the language and grasp the symbols in which it is written. This book is written in the language of mathematics. Indeed, Galileo is one of the first philosophers who realized that order is not limited to the heavenly realm, but is found everywhere, even in the changing earthly realm that was previously associated with corruption and chaos. There was no great divide between heaven and earth, only a lack of imagination which prevented us from seeing heaven on earth. For example, consider the following thought experiment proposed by Galileo, which encapsulates the physical principle of relativity. This is a very famous experience. The concept of relativity was not invented by Einstein, it was invented by Galileo. Shut yourself up with some friends in the main cabin below decks on some large ship, and have with you there some flies, butterflies, and other small flying animals. Have a large bowl of water with some fish in it. Hang up a bottle that empties drop by drop into a wide vessel beneath it. With the ship standing still, observe carefully how the little animals fly with equal speed to all sides of the cabin. The fish swim indifferently in all directions. The drops fall into the vessel beneath, and in throwing something to your friend, you need throw it no more strongly in one direction than another, the distance being equal. Jumping with your feet together, you pass equal space in every direction. When you have observed all these things carefully, thought doubtless when the ship is standing still, everything must happen this way. Have the ship proceed with any speed you like, so long as the motion is uniform and not fluctuating this way and that. You will discover not the least change in all the effects named, nor could you tell from any of them whether the ship was moving or standing still. Do you get the idea? So Galileo's description of correspondence between the motion of things seems almost trivial, but it is really critical. If we throw an apple upward in the air, we will catch it as easily while at rest as if we were moving uniformly straight forward. We won't have to adjust the strength and direction of our actions. Our body knows it, or rather it carefully adapted to this fact of nature. It is only when we consider what this basic correspondence means that we begin to experience the shock of the relativity of motion. The as if we were moving uniformly straight forward context opens up a window to our imagination in the vehicle where we had shut ourselves up. It's like if you were below deck and suddenly you open with your mind a kind of window where you see something else happening. And through this mysterious window, we suddenly contemplate the perfect copy of a vehicle moving uniformly in straight line relative to ourselves, and within it, our perfect alter ego throwing an apple upward in perfect sync with us. So it's like if you were seeing that boat moving, and then you see another yourself doing exactly the same thing that you do. So the shock of the relativity of space and motion consists in the unsettling realization that the bell-shaped trajectory of the apple observed inside the second vehicle. So the apple is going to do that kind of shape because our alter ego is just throwing the apple, and then the boat is moving, and then you see there's a kind of bell-shaped trajectory happening. So this movement corresponds exactly to the straight line trajectory of our apple when we throw it up and down. So both trajectories describe the same phenomenon viewed from two observers. This means also that in our view, the distance crossed by our alter ego's apple is greater than the one you would measure. So suddenly something that was very simple, a small distance, throw it like that. If the boat is moving very fast, you see that the distances stretch really a lot. And so the shape is completely different. How is it possible? So finding order in such unsettling circumstances first requires that we become increasingly critical of sensory experiences. This is not a small feat. It's really very difficult to do that. And we can partially understand the persistence of the Aristotelian belief that Earth was at rest, at the center of the universe, because people were unable to imagine how order could be present otherwise. If we were not at the center, everything would move really, we would feel that everything was moving. We couldn't imagine that it could be otherwise. So the displacement of Earth from its central position proposed by Copernicus in the 16th century created a revolution and presaged the age of reason. Then we must recognize our physical incapacity to observe a phenomenon from different viewpoints at once. We are always at one place, never at two. So we can imagine what's going to happen to someone else, but we cannot be that other person. We have always to connect what we experience to something else that we imagine. At all times, we are bound to a context or frame of reference, which implies that we cannot observe the paradox of Galileo's relativity. We never see that. We always see one thing, not the other. But the laws of motion exceed frames of reference and piece together what we would call the real and the imaginary. For this reason, they are said to be universal and can be written in the language of mathematics. In Newton's mathematical principles of natural philosophy, first published in 1687, Galileo's relativity was enshrined in the first law of motion, which states that every body persists in its state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by a force impressed. Inertial motion, that is, the motion of things when no force is impressed upon them, was either rest or rectilinear uniform motion, and the two possibilities being logically equivalent, you cannot make a difference between one and the other. Absolute rest did not exist anymore. Rather, things left to themselves endlessly roamed the universe in straight line. This image of eternity was a total inversion of the previous Aristotelian one, where the universe was centered and circular motion was perceived as inertial. So this is what Aristotle was writing. And we can really see that the circular motion was considered to be perfect at that time. And it was really inertial motion. When you don't do anything to things, they just turn in a circle. But with Newton, everything became very different. Suddenly, the inertial motion is really something that goes really straight forward with a constant speed. So Aristotle was writing, the circular motion itself without beginning or end and continuing without ceasing for infinite time involves no effort for the reason that it needs no force of compulsion, constraining it and preventing it from following another different motion which is natural to it. With Newton, the endless rotation of heavenly bodies became the effect of universal gravity, which constrained indifferently the apple to fall from the tree in a straight line or the moon to fall in the direction of Earth without ever touching it. The scientific revolution was, however, not attributed to the power of imagination. Rather, reason was considered the real cement that tied everything together. Imagination was more like the scaffolding of a building, something necessary only in the early stage of a construction, but that would eventually have to go. The repression of imagination in the physical sciences is clearly visible in the life of French philosopher and mathematician René Descartes, and I would like to talk a little bit about Descartes, my fellow Descartes. Descartes' career started with an impressive spiritual experience, which changed his mind durably. Who knew about the dreams that Descartes had at the beginning of his life? Have you heard about this? No? So Descartes was really someone very special, and so I think it's important to know that. This happened during the night of November 19th, 1619. And Descartes, then 23, was traveling across Europe after the end of his studies. He had stopped for the winter in Ulm, which is now, I think, in Germany, where he planned to attend the coronation of Ferdinand II of Austria as Roman Holy Emperor. It was a time in Europe of profound transformation and upheaval in Europe. And it is interesting to remark that the coronation of the new emperor coincides with the beginning of the 30 Years' War, one of the bloodiest religious conflict in Europe, with about 8 million casualties, which was really a lot at that time because Europe didn't have the kind of population that we have now. And so this war ended in October of 1648 with the Peace of Westphalia. And Europe was changed profoundly during that time, and the influence of religion would dramatically decrease in the aftermath, leaving place for the development of the sciences and philosophy under the reign of Louis XIV, the Sun King. And Descartes' career roughly lasted during that time of war, since he died at the beginning of 1650. So Descartes' sojourn in Ulm was for the young man a time of spiritual incubation, which culminated during that night with the coming of 3 very intense dreams. In the second dream, actually he was awake. It was not really a dream, he was partially awake. He heard a thunderclap which terrified him. He heard really a very loud noise. And then he saw his room filled with fiery sparks everywhere. And Descartes described this happening as a descent of the spirit of truth. A commentator would call this episode a Pentecost of Reason. This is a description of the Pentecost. So the Pentecost refers to the scene in the Acts of the Apostles, where the Holy Spirit descended upon the apostles with the sound of a violent wind, under the form of tongues of fire. So you see the fiery sparks and the fire. It's really connected to the same kind of phenomenon. And during that episode, the apostles received the gift to speak foreign languages and disseminate everywhere the new gospel. Progressively, year after year, the enlightenment from the collective unconscious that Descartes received that night took a more visible form. The following year, in 1620, Descartes wrote that he began to understand the fundamental principle of a wonderful discovery. It is uncertain what this discovery might be, but it might have been the idea that you see here, that there must exist a general science which explains all the points that can be raised concerning order and measure irrespective of the subject matter, and that this science should be termed mathesis universalis. Descartes went on studying deeply geometry and algebra, and developed crucial segments of the universal mathematics he dreamed of. In particular, he founded analytic geometry, which amalgams algebra and geometry. Further developed by Newton, this science would become the essential language to express the classical laws of motion. Shortly after his enlightenment, Descartes spoke positively of the force of imagination and compared philosophers to poets. He wrote, "We have within us the sparks of knowledge, as in the flint. Philosophers extract them through reason, but poets force them out through the sharp blows of the imagination, so that they shine more brightly." So it's pretty positive. Imagination is not a mere combination of knowledge or impressions we have. Like Flintstones, imagination actively brings together something seemingly incompatible, so realities which are really incompatible. And this is what he did, this is what Descartes did when he merged algebra and geometry. He created something new that became the language of physics. And from that clash, new reality is created, like it happened with Descartes' wonderful discovery. I suspect that when Descartes wrote these words, the shattering experience of the thunderclap, followed by the vision of the sparks scattered in his room, was still bearing on his mind. So the image of the flint that he refers to here probably comes from his vision. As the memory of this night in Ulm faded and the sparks of knowledge grew into a unique and lasting body of work, Descartes became the philosopher of reason we know. Someone pretty boring. I didn't write that. In the essay, The Search After Truth by the Light of Nature, he demoted imagination to a mere tabula rasa, a blank slate, where our senses, various inclinations, and matter impress a coarse portrait of reality. Reason is like the clever painter who might have been called to put the last touches on a bad picture sketched out by apprentice hands. However, the task at hand is too great, the original impression too faulty, disproportionate. Reason would do much better after having effaced by drawing over it a sponge all the features of the picture to begin it entirely over again, rather than lose his time in correcting it. So you see, suddenly, imagination is really useless. It doesn't serve anything. We should do better. It's just a means to reach something which is beyond, which is truth. And all the stages before that are useless and worthless. So here, really, Descartes brushes aside the active role of imagination, which always tends to be a rather disordered, emotional process. And he considered only the end goal of the philosophical process as worthy of science. This goal is truth, which the spirit that descended upon him had originally revealed. Also, Descartes' famous philosophical method, based on calculated skepticism, will aim at rightly conducting one's reason and of seeking truth in the sciences. The repression of imagination in Descartes' philosophy is deliberate, but also symptomatic of his own incapacity to appreciate the dimension of time in nature. There is a deep connection between time and imagination, and this is what I want to talk about today. In her study of the dreams of Descartes, Marie-Louise von Franz, who was one of the most famous Jungian analysts, a student of Jung, remarks that for Descartes, time itself is a discontinuous series of moments, instants. His perspective was essentially static, and transformation could only happen through collision. As a result, Descartes was unable to formulate the conception of continuous temporal change. The flow of time would later be introduced by Newton as a basic principle of physics. Time became a means to interpolate smoothly the discontinuous series of moments, as in mathematical calculus, which he created. The continuous flow was placed in the hand of God, who conducted with an inflexible law the clockwork mechanism of the universe. Time, like Galileo's ship, had to proceed with a uniform motion, not fluctuating this way or that. Absolute, true, and mathematical time of itself and from its own nature flows equably without regard to anything external, and by another name is called duration. This is what he put in his Principia about time. Time was absolute. It didn't depend on anything. It was just in the hands of God. The philosophers of classical physics believed that the world was already determined and pre-existed to their exploration, in the same way that the Americas were already there before the first European reached its shores. There was no place in it for invention, and the creation of something new, there was no place for anything new, only for discovery. The instant of the creation had happened at the origin of times, and Newton insisted, could not have been caused by the laws of motion. It was something that was beyond the laws of motion, the laws of physics. God created things, and then after that, everything went smoothly. In this light, the role of the philosopher was to expunge any subjective dark stain from the picture of the world and deduct sound physical propositions from empirical evidence. Imagination, however, did not entirely disappear, but retreated to the private sphere of the philosopher. According to British economist John Maynard Keynes, who acquired some of Newton's ignored notebooks about alchemy and prophecy, the greatest scientist who taught to think on the lines of cold and untinctured reason was not the first of the age of reason. He was the last of the magicians. So all the work that Newton did was really a very small fragment of everything that he did. He was extremely interested in prophecy and how he could read scriptures to predict what would happen. The laws of physics were just a way to predict the motion of things, but it was not going far enough for Newton. So I compare the classical pathway of the physical sciences of classical physics as to an asphalt freeway. I just want to give you an image and that I'm going to develop during that lecture. It's going collectively straight forward or occasionally circling above ground at an interchange. At any rate, it is artificially cut from the rest of the world, since an intersecting course would lead to a catastrophic collision. The result is a lifeless clockwork worldview we all know, which has showed its disastrous limit in our time. It is the image of a dehumanized world, where reason rules unbalanced, and the fantasy of control has replaced the possibility of a genuine encounter. This is a place where eros is reduced to an extreme and where little really creative spontaneously happens. On this impersonal road, nature changes like a moving picture encircling us. Giving us a powerful impression of progress, whereas we have not moved of one inch from the mechanical vehicle that transports us. It's really mechanical. We're not moving, we're not doing anything. It's just doing, the machine does the work. So let's move to chaos now. So the image of classical mechanics that I just gave may sound really harsh when we know that all the prodigious accomplishment that it led to, from the Industrial Revolution to space travel. My point here is to criticize a key aspect of this worldview. It assumes a division between mind and matter, and rejects subjectivity as a potential source of disorder. However, it is only by stopping by the side of the linear path of rigid reason and looking around that one begins to marvel at the beauty of the natural world. The 20th century saw several scientific revolutions, which undermined the exclusive pretense of classical physics. One of these revolutions started in 1889. When Henri Poincaré, a French mathematician, closely studied the stability of the solar system, as represented by Newton's laws of motion. It was already known that when only two bodies are considered, say the Sun and the Earth, the system is stable and the trajectory of the Earth around the Sun follows an elliptic curve. We all know that. It's not quite circle, but it's elliptic. But what if another body is added? It seems like a curious idea, but it's very complex actually. This problem is called the three-body problem. So suppose that we just add a third body, a small one, very small one like the moon. It's very, very small. Can we still be sure that the solar system is going to be stable? Maybe at some point everything is going to go be chaotic and go many directions. We don't see that, but is it going to be like that forever? So for that, we just need to use Newton's equations and use a second body, maybe a third body, a fourth one. And so, but let's start with 3. And even with 3, things really get very complex. And actually, the solar system is not really stable with only 3, and just a small thing like the moon. So, so Poincaré realized that it was impossible in general to determine the trajectory of the 2 bodies around the third one. Small, repeated perturbation of the small body, the third one, could not be brushed aside since they would build up over time and result in enormously large effects. He wrote, oh, you can see it. If one tries to imagine the figure formed by these 2 curves with an infinite number of intersections, each corresponding to a doubly asymptotic solution, so you see the mathematical language. These intersections form a kind of tray, a fabric, a network of infinitely tight mesh. Each of the 2 curves must not cross itself, but it must fold on itself in a very complicated way to intersect all of the meshes of the fabric infinitely many times. One will be struck by the complexity of this picture, which I will not even attempt to draw. And he was even commenting that he couldn't bear contemplating this kind of mess, this kind of disorder. It was really beyond everything that classical physics had seen before. So Poincaré was really shaken and could not bear to contemplate what lay before his eyes. Much later, when computers began to mimic the staccato of classical time, so that's what computers do. They do the same thing over and over and over. And something else happens through that. More phenomena were discovered, including the famous butterfly effect. You know what the butterfly effect is? Yeah, a small fluttering of a butterfly here can create a storm somewhere else. And suddenly, chaos was perceived everywhere as an emergent form of order, from the rugged shape of coastline, mountains, and leaves to complex weather systems. It corresponded to a geometry of roughness developed by Benoit Mandelbrot called Fractal Geometry. In Mandelbrot's words, to appreciate the nature of fractals, recall Galileo's splendid manifesto that philosophy is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures, without which one wanders about in a dark labyrinth. Observe that circles, ellipses, and parabolas are very smooth shapes, and that a triangle has a small number of points of irregularity. Galileo was absolutely right to assert that in science those shapes are necessary, but they have turned out to not be sufficient, merely because most of the world is of infinitely great roughness and complexity. However, the infinite sea of complexity includes 2 islands, one of Euclidean geometry, and also a second of relative simplicity in which roughness is present, but is the same at all scales. Deterministic chaos even caught the imagination of neuroscientists, who hope to explain consciousness as an emergent property of matter. Unfortunately, I don't have time to expand on chaos here, but the main result is that we can discover order at the edge of chaos, a rough kind of order, or rather an order of roughness. The path of deterministic chaos. So these are a few fractals. So for example, here you see a coastline, you see trees, which really follow a pattern of fractals. You have leaves, you have clouds. By the way, these clouds are not real clouds. They have been generated by computers, because computers do that. You give a pattern to the computer, and it can create mountains and all kind of things, and a lot of special effects made here in Hollywood are really using computers using fractal geometry. And it's really realistic. So going back to the image of the roads, this road is not really comparable to a smooth freeway, carefully scraped and graded and artificially covered with asphalt. Rather, it is like a dirt, bumpy road, where vehicles can move either way, circling across the landscape. Such a road differs from its natural surrounding only by repeated passage from which it emerged. So you see, it's also a road, but it's a little bit rougher. But it's more natural. Let's go to relativity. So it took the extraordinary creative mind of another giant, Einstein, to break the spell of Newton's absolute time. Einstein highly valued the power of imagination and believed it was more important than knowledge, since knowledge was limited, whereas imagination embraced the entire world and all there ever will be to know and understand. This opinion resulted from the observation of the narrowness of consciousness. He was really aware that what we can perceive and be conscious of is narrow compared to everything that is in the back of our head. In a letter to French mathematician Jacques Hadamard, Einstein detailed his own process of imagination, stressing, however, that his description did not fully satisfy him. Hadamard had asked what internal or mental images, what kind of internal words he made use of, whether they are motor, auditory, visual, or mixed, especially in research thought. So he was asking, what's happening when you make a discovery, when you do research? How do you feel in your body? What do you see? What do you hear? And so Einstein responded, the words of the language as they are written or spoken do not seem to play any role in my mechanism of thought. The psychical entities which seem to serve as elements of thought are certain signs and more or less clear images. So it's a little bit fuzzy and messy, which can be voluntarily reproduced and combined. There is, of course, a certain connection between these elements and relevant logical concepts. It is also clear that the desire to arrive finally at logically connected concepts is the emotional basis of this rather vague play with the above-mentioned elements. But taken from a psychological standpoint, this combinatory play seems to be the essential feature of productive thought, before there is any connection with logical construction in words or other kinds of signs which can be communicated to others. So what he's saying is that the essential thing is not the end result and the reasonable theory that you can communicate to people. This is really the goal, of course, but the whole process of imagination is very, very important. This is the essential part. In this description, Einstein, the above-mentioned elements are in my case of visual and some of muscular type. So he was really, it's not something that happens like that in the air. It's really something really completely embodied. It was something that he felt as visual experience and also motor experience. So in this description, Einstein integrates bodily and imaginary experiences to the process of creation. Imagination would consist in the combinatory play of non-verbal elements of thought, which in his experience surface in a visual or muscular form. As I understand it, this way a sort of coherent subtle body is produced, which then, and only then, needs to be connected to a logical language like mathematics in order to communicate with others. we are very far from Descartes' tabula rasa, where the senses are seen to be deceptive. For example, around 1895, at the age of 16, Einstein imagined that he was chasing a beam of light. He was 16 at that time. I don't know what you were doing when you were 16, but I was not imagining this kind of thing. Really not. So he was imagining what would it feel if I would chase a beam of light, if I could really reach the speed of light, and what would I see? How does the world appear to the eye of someone who goes as fast as light? Einstein realized that light would appear frozen, at rest, if he would catch up with the speed of light, or partially frozen as his speed would get closer to the speed of light. This was Galileo's relativity. This is what Galileo's relativity showed. If you go at the same speed as the boat, basically you will see it still. However, the experiments carried in 1887, so a few years earlier, by Albert Michelson and Edward Morley, clearly indicated that the speed of light emitted by fast-moving objects or slow-moving objects was always the same. The speed of light was universal, absolute. And this was a curious correspondence, which had not been taken into account by Galileo or Newton, since it was completely impossible at that time to measure such very, very large speeds. Einstein's imaginary leap proved to be the seed of his theory of relativity, of space, his theory of space-time. Einstein's imagination actually pushes to an extreme the one presented earlier by replacing the apple by a beam of light, a light beam. Instead of throwing an apple, you just throw a beam of light. So you have a kind of flashlight, you just beam it up, and so you have a reflector, and so it goes down. And so you measure the speed of the thing. So it's like apples, but it's light. Now, through the mysterious window open in our vehicle, we contemplate the second vehicle moving uniformly in a straight line relative to ourselves. Within it, our alter ego plays with the light beam going up, then reflected down. As we do exactly the same thing. So now let's say, for the sake of this imagination, that all the equipment is carefully calibrated so that our light beams take exactly 1 second to go up and down. It's not really possible because, as you know, the speed of light is very big. And so in 1 second, the beam of light would cross 186,000 miles. So it's a big vessel, big ship. Let's assume that it is so. So the important factor here to remember is 1 second is equal to 1 back and forth motion. Okay? According to Galileo's correspondence, what we see when we look at our light beam is identical to what our alter ego sees when he looked at his own light beam. So I do something and I don't see anything strange, and my alter ego is doing the same thing, is having his light beam go back and forth, and so everything is 1 second for him and 1 second for me. It's only when I begin to look at what my alter ego is doing that things get a little bit tougher, because suddenly, because the speed of light is exactly the same for all the observers, then I see also the light of my alter ego go to the same speed, which is the speed of light. But if you remember, because the ship is moving, there is the length is different. It's not just up and down, but it's going in this kind of trajectory here, which is much longer. So this means, and if the speed of light is exactly the same, if the distance is larger, it means that 1 second for the person in the other ship, alter ego in the other ship, it will correspond to many cycles for me. So it means basically that when something moves, then time goes slower. 1 second for him will maybe be 10 seconds for me. This is really the core of Einstein's relativity. The fact that the speed of light is the same for everybody. And this is really shocking. It's really the same experience that Galileo made, but with a beam of light. So this is really Einstein's special relativity in a nutshell. Time, or rather duration, is relative to observers and appears to flow at a slower pace for moving objects. Light only is constant. Everything is not. This strange idea is heralded by the famous twin paradox. Have you heard about this paradox? And it's not sci-fi. Imagine that you have twins and have a pair of those at my house. I have 4-year-old twins. And so imagine that maybe when they're 20, they decide one is pretty intellectual and doesn't want to move too much. The other one is pretty, wants to move. So imagine that in 16 years from now, they decide to take a spaceship. Maybe it will be possible. Something that goes very fast. And it decides to go to another planet. And so it's according to his clock, the travel is going to take 20 years. So he goes back, 10 years to go, 10 years to come back. And, well, he returns triumphantly and he feels, well, I'm 40. My biological clock says that I'm 40. So everything is fine. But except that because he was moving, he came back. And his twin probably will have aged 40 years. So he will see his twin. For him, he will be 40 of age, but his twin will be 60. This is shocking. No? And this is relativity. Time is relative. Time depends on motion. And it's not sci-fi. Sci-fi uses that, but it's real. So according to Einstein's special relativity, we cannot think of space and time as separate factors. Rather, they form a whole called space-time. In space-time, time, like imagination, is embodied and relative to the observer who measured it. Whereas light becomes a synchronizer of events, which keeps the coherence of the cosmos. Light is very important. Einstein was even saying that he would spend his whole life studying light. Light well, you have light here, you have light everywhere. It's really around us. It seems to be very simple, but it's probably the most complex thing that you can believe. It's really very, very profound. And a lot of revolutions in physics came through the study of light. But there's a lot that we don't know, and I wouldn't be surprised if one day we can connect mind and matter by studying and finding new properties of light. Einstein would later generalize his discovery by including another insight. Gravitation is not a force in the Newtonian sense of the word. It's not a force that pushes things. Rather, gravitation corresponds to another kind of inertial motion. Inertial motion, if you remember, is something that happens when you don't force the motion. So you may wonder how come that things move according to gravitation if it's not pushed by something. Well, it's inertial motion, but in a very curved space-time. So what Einstein realized was that you had to understand gravitation and gravity as something where the way you put things with a lot of equations was the fact that energy, and mass is energy, can curve space-time. So the Earth which is very massive, is going to curve space-time around it. And the moon is going to just go in a straight line on this curved space. So, but because the space is curved, basically it's going to turn not in circles, but in form of ellipse. So once again, Einstein reached this conclusion using imagination. He wrote, I was sitting on a chair in my patent office in Bern. Suddenly a thought struck me. If a man falls freely, he would not feel his weight. It seems really stupid, but once again, it's like you have to catch what it means. If someone falls freely, you don't feel your weight. You need a lot of imagination to imagine that, because you feel like, oh, actually when you fall, you're weightless. You're just falling. But because space-time is curved, well, you're just going in a straight line according to this curve. I was taken aback because it's so shocking. The simple thought experiment made a deep impression on me. It was what led me to the theory of gravity. So you see how Einstein was really trying to understand how he was moving and doing things, and how he would create new ways of looking at the universe this way. And personally, I imagine Einstein playing with gravity and developing new visual and motor impression by leaning on his chair in his patent office in Bern. You can see him moving with his chair and doing all kind of things like that. And maybe one day he moved a little bit too much to the point of falling down. And he thought of gravity might have struck him like Newton's legendary apple when he touched the ground. So I just imagined him falling down and suddenly having this insight. Oh, I didn't feel my weight. I'm just trying to spread rumors. Unfortunately, I cannot go too far in that direction again. I will simply mention the fact that the stronger gravity is, and the slower time passes, which is again something a little bit funny. That means, for example, that someone traveling for too long in the International Space Station will also travel in time. For example, it was estimated that Sergei Krikalev, who holds the record for the longest amount of time spent in space with 803 days, 9 hours, and 39 minutes, also traveled in time because he was going fast and because gravity is a little bit not as intense above the Earth. And so he traveled in time of 0.02 seconds. It's not a lot. It's not a lot, but it does exist. You can travel in time just using relativity. But if you take, for example, another case, which also comes from general relativity, imagine, for example, a black hole. A black hole is something which is also predicted by relativity. And we should have maybe the first realistic images of a black hole. The black hole that is a supermassive black hole that is at the center of a galaxy in a few, maybe months. What we have now is just artistic images of black holes. But now some images have been taken and people are beginning to collect the data, and we're going to see a real black hole, close-up of a black hole soon. But imagine someone falling into a black hole. In a black hole, the intensity of gravity goes to an extreme, it goes to infinite. And so it means that time is going slower. So imagine that someone is falling in that black hole. What would take maybe 1 second for that person falling, having a clock, maybe for someone outside the black hole from where we are, it would take millions of years. Because suddenly the effect is way bigger. So, and the whole fabric of the cosmos is like that. It involves this kind of process. Another revolutionary consequence of Einstein's general relativity is the fact that our cosmos is expanding and even accelerating. There was an origin of the cosmos called the Big Bang, which we can only approach by running relative time backward until we reach a singular instant of coming to being. The amount of imagination which led to general relativity, so it's just, you know, these two imaginations with the light and also falling from the chair or whatever, these very small things, these small impressions and this small imagination led to very important equations that we started to study more deeply. And so the theory of the Big Bang came out of that. And also the fact that there was an origin of the cosmos. So it's really coming from very small seeds. It's pretty impressive. So we cannot really know what happened before the Big Bang because we just go backward in time. And we know that the theory of general relativity is going to collapse at that time. So we know that we need more imagination if we want to know what happened at that time. And if we want to go beyond that, we need quantum mechanics. Quantum mechanics adds another level of imagination to relativity. And it's really what may tell us what happened at that time of the creation of the Big Bang. So if we had to compare so maybe the black holes will look like that. But actually the photos that I saw, you have kind of circles of light. Black holes can be very bright. They're not really black. They're black at the center, but not around. So they can be very bright. So taking again the image of the road, what we need to do if we want to develop this image is that we need to include the dimension of time. Because when you go in the previous images that I gave you with classical physics or chaos, the time was just implied. It was not showed physically in space. So for that, I would like to take the image that quantum physicist Brian Greene, probably a lot of you know about him, provided to illustrate what relativity means. He was saying, well, even when we are at rest, when we don't move, we may not move in time, in space, but we move in time. There's no way we can not do it. It's unwilling. Whether we move or not, we're still moving, but we're moving in time. And time is real. So whether we like it or not, when we're at rest, we're still moving in that car that goes straight forward. Okay? So what happens when you see, if you see another thing, another car moving and taking another road, it means that that car is moving physically in space relative to us. And what it does is that it diverts part of the amount of motion that we had northward. And you see here, because it moves sideways, the blue line here means that time goes slower than the red one. So it's a nice way of looking at things. Do you understand the idea? Yeah. And so if you take general relativity, then it goes even beyond that, because suddenly, well, space-time is curved, and so you don't need to use, you don't have to use straight lines, but you have to follow the curves of space-time. And so you can have things split path, and so it becomes really more complex. So this would be the road of relativity. So, well, Einstein valued deeply imagination, as I said. Yet, to paraphrase Keynes, I believe that Einstein was not the first scientist of the age of imagination. Rather, he was the last of the classical physicists. He was the last of the age of reason. Because when imagination becomes integral to knowledge, seemingly dangerous discontinuities suddenly multiply in the way. Compare that to suddenly you see a flower coming out of the asphalt. And for me, this is really quantum mechanics, an image of quantum mechanics. Knowledge becomes fundamentally uncertain and stained by a dangerous subjectivity. This fact deeply concerned Einstein. In his terms, if one asks what is characteristic of the realm of physical ideas independently of the quantum theory, then above all the following attracts our attention. The concepts of physics refer to a real external world, so the world is out there. It's not connected to me. I discover it. I don't create it. I have no connection to it, really, that is creative. There's no participation. So it refers to a real external world. That is, ideas are posited of things that claim a real existence independent of the perceiving subject, bodies, fields, and etc. Further, it appears to be essential for this arrangement of the things introduced in physics that at a specific time, these things claim an existence independent of one another. So things need to be existing out there, but also they need to be separate. Things, I'm not you, or any one of you. I'm separate. I have my own existence. That's what he says, and it's really reasonable. Without such an assumption of the mutually independent existence, the being thus of spatially distant things, an assumption which originates in everyday thought, physical thought in the sense familiar to us would not be possible. Nor does one see how physical laws could be formulated and tested without such a clean separation. So if I'm not different than other things, then I always interfere with them, all the time. So you cannot do science in that way. Einstein's argument about the mutually independent existence of spatially distant things goes against a famous quantum phenomenon now called entanglement, which he contributed to discover and qualified negatively as a spooky action at a distance. Einstein failed to imagine that there might be another alley of knowledge where a perfectly synchronous dance between separate partners takes place. This erotic bond leading to wholeness in the material world cannot be reduced to the basic mechanical logic of action-reaction, and unfortunately almost disappeared from the Western everyday thought. According to quantum mechanics, reality is not something given, something that we discover. It is something in the making. It is something in the making, which progressively rises from the darkness of its metaphysical chrysalis through a heated process of scientific differentiation. Reality is like the mysterious flower piercing through the asphalt that I showed. Also, when Einstein assumed that real existence is is, or rather should be, independent of the perceiving subject, we need to ask, how can he possibly know what real existence is? Such a statement on his part is clearly metaphysical and cannot be taken for granted. And really, when we want to do science, we need to reject all metaphysical statement, and we need really to be sure to look at all the things that can be tested. Otherwise, you may just be like Newton, who thought that time was absolute. It's not. In fact, quantum mechanics repeatedly provided empirical evidence of the contrary. The phenomenon of entanglement just mentioned is a well-known counterexample. In addition, there are countless well-established quantum phenomena which indicate that the physical world at bottom is contextual. I would like to say a few words about the idea of contextuality. Contextuality is an expression of the simple but revolutionary fact that nature may appear in a different guise depending on the context, yet it will always remain true to itself. For example, depending on the context of the experience, light again, will behave like a flux of discrete particles or like a continuous wave. It's the same thing. But depending on how you look, depending on the context, it will take different forms. And still, it's the same thing. So lights, waves, and particles are two very different orders of manifestation of the same indescribable phenomenon we call light. This is a famous wave-particle duality which extends to all forms of matter at the elementary level. And it shows that discontinuous events might, in another context, be experienced as a continuous field. Just as an aside here, I want to tell you to make an analogy with another phenomenon in the psyche, which is really deeply contextual. It's what Jung called archetypes. Archetypes are things, I don't know if you can say thing, but it's something which is really beyond what can be described. It really goes beyond that. Then you have archetypal images or archetypal experiences, which actually represent exactly the same core, which are the archetypes. But the images will always be contextual. And it's the same thing for light. Light is something which is beyond description. But depending on how you observe it, it's going to be either a wave or a particle. The contextuality of quantum mechanics adds a prospective element to our conception of reality, which is open to individual participation. This is an experience in quantum mechanics. It can be very complex. The inalienable capacity to set up the experimental context for questioning nature is still granted to us. We still can do it. We can question nature. Nature will not interfere with our free will and conspire to impose on us a question that suits her. However, what we value most about human agency must be conceded in equal measure to nature, which will respond to a question in a way we cannot fully control. Moreover, we can be sure that nature's response will display the most refined kind of coherence and order and integrity, which we are still struggling to understand. In a recent paper, quantum physicist Christophe Fuchs puts it in the following poetic words. So what I mean with the previous slide is that there is a reciprocity We are not, when we touch something, that thing touches back. He wrote, a grain of sand falls into the shell of an oyster, and the result is a pearl. The oyster's sensitivity to the touch is a source of a beautiful gem. In the 75 years that have passed since the founding of quantum mechanics, only the last 10 have turned to a view and an attitude that may finally reveal the essence of the theory. The quantum world is sensitive to the touch. The erotic sensuality we discern in the background of this modern description of the quantum experience brings to the fore something totally missing in the classical concept of reality. There is a reciprocity between man and nature. Classical physics is essentially non-contextual and pays for its uprootedness by reducing nature to a succession of meaningless, abstract events. On the contrary, the concept of reality presented by quantum mechanics is more like an oral language, which will never be fully represented by a mere combination of signs on a piece of paper. It cannot be reduced to reason. The simplest quantum evolution will also never be captured by a cinematographic succession of images. We see movies, for example, and that just a succession of snapshots. Reality is more complex than that. It's not that. When we see in a movie, it's just a classical representation of reality. The world is more complex than that. We could say that the indisputable resistance of nature to one-sided objectivity is what makes it real, since truly, how real is something that does not resist our willful actions. The fact that it resists us, it is really what makes it real. So, returning to the image of the road, quantum mechanics is better represented by a crossroad. The ancient Greeks had a profound sense of the essence of a crossroad and placed there what they called a Hermes, and hence with the statue of the god Hermes, something nominous endowed with the creative energy of the trickster awaits us at a crossroad. We have to stop here. We cannot just go and move. We have to stop. Really, sometimes when I give lectures, I say that quantum mechanics is a coherent theory of now. Not of duration, not of things passing. It's really a coherent theory of now. Stop here and wait and see what's happening because you participate to it. So that's why also they put, sometimes you see that there is a phallus. It's really about the creative energy coming out of this crossroad. In quantum mechanics, modern science has rediscovered this creative source of everything there is in the universe. And it's probably why it's the key to knowing what the universe is about, how it was created. We cannot just say God did it, but we can go beyond if we study quantum mechanics. Einstein's theory is, however, legitimate and should not be taken lightly, since in many respects, quantum mechanics consists in a return, but at a different level to what quantum physicist Wolfgang Pauli called the magical animistic conception of nature. So it's returned to that, but at a higher level. And it was a kind of conception that preceded the scientific revolution. In his study of the influence of the archetypal ideas on the scientific theories of Kepler, Pauli tells us that during this pre-scientific time, the view of the universe was not as yet split into a religious and a scientific one. The two were really connected together. The crossroad of quantum mechanics rounds off the scientific revolution of the 17th century and gives the opportunity to reintegrate what was left behind and complete the radical transformation of the Western civilization, provided our concept of reality can take the quantum leap. In particular, we must realize that the road we have collectively taken is not separated from the other roads left behind. They're still there. They're still here in the crossroad, at the crossroad. All the possible roads stick together. Using the Greek equivalent of the expression sticking together to describe the effect of the mysterious glue which binds things together into a state of wholeness, there is a coherence. Coherence means sticking together in Greek. So there is a coherence in the ensemble of these roads. The road taken might be actual, but the other viable roads are no less real because they did not become actual for us. Quantum mechanics has struggled in the past with the qualification of the alternative roads. Are they potential, like in the Copenhagen interpretation of quantum mechanics, or actual, but existing in a parallel universe, like in the many words interpretation? The word counterfactual, taken from logics, is sometimes used. Counterfactual. And I like this word very much. The prefix counter means go against, but also introduces the important idea of counting. These counterfactuals may go against facts and look imaginary, yet they must be counted since they contribute to reality. We need to include them. Neglecting one of them leads to an incoherent, one-sided image of reality. To hold a coherent view of reality, what is needed from us is a genuine experience of the numinous center, from which all the roads radiate. Here is the universal core where reality takes root, and where the multiplicity of knowledge becomes one. Here, for example, quantum mechanics is not so different from the animistic conception of nature, and the indigenous and the Western mind meet. Like Einstein, we may experience fear at the sight of the counterfactual roads, or nostalgia of an age that never was, or guilt for the description of what might have been. Such regressive feelings serve a meaningful purpose by pointing to the numinous center and connecting us together. What I mean is that I really feel that this connection and how we feel about it is really the source of emotion and feelings. I don't know if you've seen, for example, La La Land, the film La La Land. Some of you may have seen it, but at the end there is a very, very emotional scene where the guy plays a piano in front of the woman whom he loved at some point. And so we see everything that could have happened. But, well, things that might have happened or not, we don't know. But it becomes very emotional because we have the two sides of the story. So we have something where the two paths meet, and we see the center of it. And you cannot express this superposition of two stories without music. It needs to go there, you need music. Music is really what touches the soul and creates emotion. Others, again, will hear the call and progressively discover at the center the natural place where their fate is attached. In working on passionately giving voice to the neglected spiritual presences in our time, they may experience a deep sense of meaning and intimacy with the cosmos. this is, I guess, what people do here at the University of Philosophical Research, trying to look at other traditions and try to connect to the cosmos through this discovery. Wolfgang Pauli even talks about a feeling of happiness and wrote, "The process of understanding nature, as well as the happiness that man feels in the understanding, that is, in the conscious realization of new knowledge, seems to be based on a correspondence, a matching of inner images pre-existent the human psyche with objects and their behavior." Here we really see that imagination is very important, because it's about matching of something unconscious and something that does exist outside. This passage concerns specifically scientific discovery, but can be taken to describe the reciprocal process of connecting to nature. An exceptional value is given here to what Pauli called the instinct of imagination, and for him the instinct of imagination was the archetype. It becomes a principle of a correspondence between man and nature. We know that this idea goes back to ancient times and was given a scientific grounding by C.G. Jung with the concept of the archetype. For Pauli, it is obviously out of question for modern man to revert to the archaistic point of view that paid the price of its unity and completeness by a naive ignorance of nature. His strong desire for a greater unification of his worldview, however, impels him to recognize the significance of the pre-scientific stage of knowledge for the development of scientific ideas, by supplementing the investigation of his knowledge directed onward. In other words, one must know the spirit which drives us. Otherwise, one gets possessed by it and falls victims of its more than human operations. We need to not just look outside, but we have also to look inside, and we need to do this matching. Consciousness had to develop to an incredible extent to recognize the objective value of imagination within us. And it corresponds to something also outside. So it's really integral to nature. Reciprocity entails in turn the restitution to nature of its capacity to imagine. Quantum mechanics is the only science where such a movement occurs. For this reason, the quantum is widely believed to provide in the future the element of a new creation story. I wanted to share a dream with you. I don't know if you want to hear it or if it's already too long. Yes, please. Okay. My presentation would remain really abstract if I did not show you an image of this crossroad, something that came in my life, actually many times, but it's one of them. And this was shown to me in a powerful dream I had in 1997, when I was completing my PhD in quantum physics. And the dream is the following. I am floating in deep space, near the center of the universe, which is like a vortex or a spiral galaxy with alternating bright and dark arms. Suddenly, I notice the presence of a gigantic male being by my side. This man tells me of a new hypothesis. This is a term he used, hypothesis. He said, notwithstanding its darkness, the center of the universe is an immense ocean. This idea is quite surprising to me, since the center is traditionally associated with fire, not water. Then the man touches the vortex, which whirls and opens largely. And suddenly I find myself at the surface of the ocean, this big ocean at the center of the universe. I am told that the heat of the water is beyond imagination, millions of degrees. yet it does not harm me. The abysmal depth underneath me is counted in light years. It's really unfathomable. And really, this depth is so great that I'm just at the surface, and it scares me to death. I'm really frightened and terrified at the perspective that something monstrous, a kind of monster, would just surface and just eat me. In a second time, I am showed the mystery of life, and I see a small drop of this immense ocean coming close to a round, earthy body, dry like the moon. And it appears, all this is in the obscurity. And so I see the drop moving in the direction of the body, and when it gets very close, I see that the body begins to really quivers and visibly undergoing some tremendous internal transformation. And the drop itself is changing too. It splits into four identical parts, distributed in a square around the body. I cannot see the rest of the process, but remain really in awe before the little I have just witnessed. What I realize at the end of the dream, what an extraordinary potential for creation is contained in a single drop, and how infinitely more is concealed in the immensity of the ocean at the center of the universe. I'm really in awe when I saw that. I realized that. Finally, in the last scene of the dream, I am told that a scientific expedition is heading towards the center of the universe. It will take many, many years to reach it, and I'm happy to know that I'm part of the crew. Very briefly, the dream describes what science is essentially about, a path leading to the core of reality, which became my path. This is why I had that dream when I became a PhD in physics. The evocation of the boiling ocean with its boundless depth reminds of the primordial state of the universe, just a moment after the Big Bang. We tend to see the center at the confines of the universe, or long ago at the beginning of times. But in fact, it is everywhere, in particular where we stand now. The universe is continually in a teasing orgy of creation, as Christophe Fuchs once declared, boldly adopting a sexual imagery that the dream author uses. There's something sexual about this fertilization, of course. It might take many years before we reach this simple conclusion. While I was reflecting on the dream in preparation for this lecture, I wonder if I could say more about the gigantic male figure floating nearby the center of the universe, the maker of the new hypothesis. And my intuition was that he was related to the god Hermes, standing at the crossroad of reality and inspiring insights on the creative source of all there is. I experienced again the fright of my dream when eventually I found and read the first sentence of the Corpus Hermeticum. The content of this famous opus, which goes back to the beginning of the Christian era, possibly even further, was unknown to me. I didn't know that book, and it begins like that. Once, and Hermes Trismegistus speaks. Once, when my thoughts were centered on true reality, and my thinking soared high and my bodily senses were restrained, an enormous being completely unbounded in size seemed to appear to me and say to me, "What do you want to hear and see? What do you want to learn and know from your understanding?" The enormous being was Poimandres, the shepherd of man, who is everywhere with man. Poimandres' way of teaching is visionary. In an instant, Poimandres changed appearance, and everything was immediately open to Hermes. Hermes saw an endless vision in which everything became light, clear and joyful, and in seeing the vision, he came to love it. After a while, darkness arose separately and descended fearful and gloomy, cooling sinuously so that it looked to him like a snake. For me, I saw then this darkness change into something of a watery nature, indescribably agitating and smoking like fire. For me, I was seeing my galaxy in the form of a snake, and I was seeing the fire at the center of the ocean, the boiling ocean at the center of the universe. The similarity of this vision with my dream is striking and continues with the myth of creation and an evocation of the mystery of life. Far too complex to be described here, but let us just say that it involved the love and embrace by nature of the first man created by God in its image. It also emphasizes the sacredness of life. The image of the scientific expedition in my dream is paralleled by a rising of the senses through the 7 planetary spheres, which comes with profound ethical challenges. Each sphere has its demonic power, longing, arrogance, recklessness, and greed, to name some of them, which must be made inactive. The goal is an entering into God and a surrendering to God. Since this is a final good to those who have received knowledge to be made God. This way also is also the only one road from here to the beautiful and combines reverence with knowledge. Our modern scientific path to true reality is in fact ancient and indissolubly bound to what we have left behind. The gnose of Poimandres first flourished at the beginning of the Christian era, then seemingly disappeared from the Western civilization for centuries, but rose again from its eternal rhizome during the Renaissance and produced the flowers of alchemy and Hermeticism. Then it seemingly went underground again during the scientific revolution, but did it really? Or was it working as a counterfactual reality in the background of history? The cosmos has been sanitized of its demons, and the rise of our senses has been replaced by rocket ships, the Hubble telescope, and other technological achievements. But the ethical responsibility towards the creation remains. When we turn our back on the maker of hypothesis and the source of imagination, we are also removed from the center of the cosmos and forget our own ethical connection to nature. It is my belief that a new age of imagination has begun, which hopefully will balance the excess of the scientific age and restore a genuine and more grounded sense of spirit in nature. In a letter to Jung written in 1947, quantum physicist Wolfgang Pauli described the possible goal of this journey and speaks about the close fusion of psychology with the scientific experience of the processes in the material physical world. He continues, I love this image. It is a long journey, one we are only just setting out on, and it will especially entail, as a modifying factor, constant criticism of the space-time concept. Going hand in hand with this, apparently, is a criticism of the basic idea of classical natural science, according to which it describes objective facts to such an extent that there is absolutely no link between them and the researcher. Modern microphysics turned the observer once again into a little lord of his creation. And I wanted to emphasize the his. It means that the image of the universe that we have is personal. And quantum mechanics is about personal belief and how we can find something common to each. It's really the goal of science. I started this lecture with a question about the role of imagination, And would like to conclude with another question which you may want to use as a premise, a kind of new thought experiment similar to Einstein's fantastic imagination, but pursuing a beam of light. How would your perspective on reality transform if you discovered that deep down you are intimately bound to the center of the universe in its immeasurable capacity to create? How would you feel? Well, thank you.